Okay, so we are live. So I haven't finished grading some things. I apologise for that. It's been a busy week. Partly because my wife and daughter have been on spring break, so there's lots more people in the house than usual. So we've done with the first half of the course, right, of Capstone 1, right? So now we need to change gears a bit. What we did in the first part of the course was figure out what we want to build, who we're going to build it with, and hopefully some of the things we know we need to do. And now the next step is to flesh out the design, make it real. We're not going to actually necessarily build anything yet, although you have some of you have some pieces of hardware to play with, to try things out. But we still don't have a clear understanding of, well, I don't have a clear understanding of exactly what you're going to build and what needs to be built. So let's see where we are. Right, not much time. I don't know. I didn't remember to reach out to Professor Braverman until late last night, so I haven't had a response from him yet. I don't know whether these two are going to be in this order or whether we might need to swap them around. I think last time Professor Braverman had his, was it Professor Broderick? Might have been Professor Broderick had his 498 student final presentations the week before finals week. So we'll have to see what Professor Braverman wants to do. And part of this course for you is to watch those 498 presentations. So some of the things that you're going to get out of watching those 498 presentations are, oh no, I've bitten off more than I can chew. Or, oh no, I haven't written down enough of what we're going to do, or we're not doing enough. And both of those are okay reactions, right? Every project is a little different. Every project has its challenges. But it's good to see what other students do in their capstone projects and what they finally come up with. So we'll have a look at that. So as I said, I probably should try and shift gears like this a little earlier in the semester, but I do like spending a bit more time on the ideation and the thought that goes into, deciding what we're going to do. I think it means you get more of an input into what you're going to do. I know when I went through, I couldn't come up with my own idea. I had to sign up with one of the professors' posted projects, and most of those posted projects were related to their research topics, which is also not a bad thing to do. But I thought it was okay. The project I liked, but it can seem a little bit like you're doing work for the professor rather than actually getting a project that you like. And then Fairfield University does, they call it Senior Design Project, but it's basically the same thing as Capstone. They do it a little differently. They try and engage local companies for the students to do projects for the local companies, and that can be good, particularly if the local companies are liable to hire people. I haven't quite figured out how they do that, but if I stay there a little longer, we'll see if we can do something similar with the capstone projects the capstone projects here. So what we need to get by the end of the semester is a preliminary design, and it has to be a reasonably technical document. And I'll show you some examples of the preliminary designs from my last cohort of students. And that's where we are. We went backwards for some reason. Okay. So back to the design V, and now we need to do most of this. Effectively, the prototyping and detailed design is the first part of 498, but really it probably captures parts of the detailed design, because oftentimes what happens over the summer is you have another thought about what you're going to do, and that may even change the high level design. Hopefully not, but it certainly can change the detailed design. Maybe you do a bit of reading, or you watch a TV show or a YouTube video that does something interesting. So I don't know how many of you are in Broderick's, what's he called it? Educational Thunderdome? Maybe he's changed the name, his Discord server. But there was Chris Farley, one of the former students of CET, has always wanted to build a railgun, and he wanted to get a capstone project together about building a railgun. That's okay. Then he had some other rather dangerous and destructive other suggestions for capstone projects, which I hope you didn't see, but thankfully you didn't see them before you chose your projects. So we'll have to see if others.
Actually, I was thinking about changing our project.
Yeah, it was pretty funny. Yeah, Chris is a good guy. He is full of memes, but he's a good guy. Despite his what's the word? Over dedication to the Tesla brand. Anyway. Okay, so basically half of the work in Capstone 1 is done already, and we've got the other half to do. Right, so the preliminary design document, the physical document, that's the thing that is going to make up 30% of the remainder. Well, I suppose it's 60% of the remainder, but 30% of the total grade for 497. And the design review, which is another presentation, is 20%. And there are 3 projects. I think it's good. I think I can spend more time with each group with only 3 groups. But I the last cohort I took through had 6 groups. I had 18 students, so 6 groups of 3. And it actually worked out pretty well. I was pretty happy with their outcomes. I was pretty happy with the way each team worked together as a team. And it just worked. That reminds me. Every week, every Friday, during this lecture, or maybe oops, this is the wrong one. I got the previous one. I would like you to fill out that self and peer assessment form, right? And what I've done is I've put the links into each group's journal, okay? And so the link is there. I don't know why the first one came up prettified, but the other 2 didn't. I must have done something different with the first one. But please make sure you do those now, but every week. And I don't know whether it works. I just want to see that. I think I told you the previous one of the professors at Fairfield suggested a more sort of Full Metal Jacket quiz at the end of semester about peer review. And that's okay, but it doesn't tell me how things are progressing. And I wanted something lighter weight and easier to just click and you're done, so that it doesn't take you long. But then I also wanted it to happen more periodically, more often, just so that you get, because sometimes I don't know, during midterms or whatever, you'll all click seldom contributed, and that is okay, right? That happens. The issue will be if somebody is always graded as seldom contributing, and particularly if they also then grade themselves as contributing lots, right? So I just want to make sure that all the teams are humming along and getting stuff done. Okay. I don't know why it goes backwards. So, as you are probably aware, I am stealing just about everything I do in this course from Professor Broderick. I've put a few wrinkles in it, so it's a bit more interesting for me. So when I teach a course, for example, I've taught circuit analysis CET497 since 2017, I think. Fall 2017, I think, is when I started. I would get very bored if I taught the same material again and again and again. So I went to, I think CCSU had a sort of a teaching workshop, and one of the people there had this really nice idea, and she called it a +1, right? So what she meant by that is, if you're teaching the same thing again, don't just teach it again. Think of one thing that you can add or change or do differently each time, and see about doing that to change it up a bit. And I think that is really good. I personally think that teaching well is about two things. It's about professor engagement with the students, and it's about professor engagement with the subject. And if one of those things doesn't work, then it's not great. It's okay, it's not great. But if both of those things don't work, then it's awful. And I try to do both. So I try to keep engaged with the subject, and I try to get engaged with the students one way or the other. So let's have a quick look at, I'm not going to go through the whole thing, but Professor Broderick's capstone material. There he is, Professor Broderick. Oh, did you see, I don't know if you saw in his student lounge, that was his deck this morning. That was a little, I've got rain here, but that was that's a little much, I think, for mid-April. Anyway, so there's his capstone stuff, right? So there's a syllabus, and this isn't really relevant, I suppose, because like as you can probably see, I've completely stolen it from Professor Broderick. And let's see what he's got under preliminary design, right? There's a presentation. So there's a checklist. I have taken the preliminary design review out of the assessment. And I didn't see, so the idea being that the whole class assesses each project or each preliminary design, and that's okay. I think it's good to get feedback from everybody, but I didn't see it necessarily contributing to the grade. For example, so these complies with comment and non-compliance. I could see complies with comment being good or complies with comment being bad, and I'm not sure what to make of that as a grade. And if that's the case, then those two, complies and complies with comment, are the same. So are these just a check mark then? And I wasn't sure. But I still like the checklist, right? Subsystems are identified. Interfaces are clearly described. A system block diagram is clearly drawn. Operational objectives are defined. Success criteria are defined and agreed upon. Sufficient detail exists to begin prototyping subsystems, right? If you were doing this in a company, the next step, the prototyping, which is the first half of 498, that's when you start spending money, right? At the moment, mostly it's been research and talking and writing stuff down. But as soon as you hit the button on doing the prototyping, you've got to buy kit. You've got to buy maybe manufacturing machines. You've got to buy materials. And the preliminary design review, we called it PDR at United Technologies, when it was called United Technologies, is it was actually three options: a go, a no-go, or a redirect. And redirect meant you had to redo the presentation because somebody didn't like something in it. And if you didn't get a go, that meant you couldn't move on to the next step. And that's why the review we did last week with the presentations at United Technologies, that particular review would be called CONDR, or the Concept Design Review. There's a few others around. I think the one after preliminary PDR is CDR, Critical Design Review. And then I forgot what they called the one after that. I'll have to see if it's available somewhere on the internet. But anyway, so that's a key. Number 6 there is a key one is in the go no go decision, right? Did we actually address the problem that was raised in the preliminary? Sometimes you've got to redirect. Sometimes in startup language, sometimes you've got to pivot, right? You've got to change direction and do something a little different. That's okay. If you have, you need to show that you have, and you need to say why you have and why it's of benefit, right? Again, we need to go into a little bit more detail on what the team member roles are. When this document is done, there should be a list of deliverables, and maybe we're going to take a bit of time to get to that list of deliverables, and each one of those deliverables should have a date and a responsible person, right? And the date feeds into the schedule, and then obviously each of those, there might be some budgeting requirements for each deliverable. Okay, so the big thing about, let's just go back. Right, so I just went through the checklist. There's rubrics for the presentation and the design. Let's see if we've got some slides. Right, so that's the sort of thing that you should put in there. It's short but sweet. Right. Block diagrams, schematics. You should, if you need to develop electronics, you should have a diagram, even if it's only a wiring diagram. You should be able to use CAD or something like that to show how your electronic components fit together. I'm pretty sure CAD has components for things like Raspberry Pis and Arduinos and sensors and all that sort of stuff. Sometimes flowcharts are good, sometimes pseudocode's good, state diagrams sometimes. Okay, but have a excuse me, this is about the presentation, but have a look at that. Have a look, in fact, at all of Professor Broderick's stuff about Capstone. Okay, the other thing I had on that slide, where have it got to, is this blog post from Stack Overflow I felt was a really good guide to writing a technical document, a technical specification, which is what your preliminary design document is. It's a technical specification. Right, and I'm not going to read it to you. I suggest you read it yourself. And let me just, I've been meaning to keep a copy of that. And let's just do that. I have my own OneNote notebook for stuff that I like clipping. Right, so what is a technical specification document? A technical specification document outlines how you're going to address a technical problem by designing and building a solution for it. It's sometimes also referred to as a technical design document, a software design document, or an engineering design document. It's often written by an engineer who will build the solution or be the point person during implementation. But for larger projects, it can be written by technical leads, project leads, or senior engineers. These documents show the engineer's team and other stakeholders what the design, work involved, impact, and timeline of a feature, project, program, or service will be. And that's what you've got to put together, right? It's a specification for what you're going to build. And I'm not going to read through this. I suggest you read through it, right? The nice thing is that it's got a bit of a template, right? Title, authors, team, reviewers, created on, last updated. If you're using an issue tracking system, put some information about that there. So I might show you an example of an issue tracking system later. Have an introduction, right? Oftentimes you may want to include a glossary for acronyms or new terms, and just to keep track of what you're saying. For example, the security industry has a variety of different terms, and maybe they're not relevant to the security project, but things like PIR, right? Passive infrared sensors. It'd be nice to collate a list of terminology for your particular area. And then context, goals, things that are out of scope, stuff that you'd like to do but not this time, and then any assumptions you're making. Right, so there's lots of things you could do. Right, I'm not going to read through all of this, but you can see that there's lots of stuff you could do. What I might do, and I haven't done that yet, let me write that down so I try and remember. What I might do is I might put together a template for this outline, right? Because it's I think it's pretty important to get it right. Okay, I've been talking too much. Any questions, comments, thoughts? Does that sound okay? Nothing too scary there? Everybody's on mute. Okay.
Yeah, no questions, Professor.
Okay, good. So I thought it might be good to have a quick skim through some of the other projects, the last cohort that I took through, and I'm going to start with this one. This is motion powered light, right? Matt and Wei did this one. And this one still, all of these have their issues. None of them I gave 100% to, but I think it's this one is, I think, one of the better ones. Right, again we've got our use case diagram. Right, and so what this was about was to for remote areas to be able to have a motion-powered light, a flashlight or a reading light. And so one of the key pieces, or two of the key pieces, one of them was whether they use a rechargeable battery or a supercapacitor to store the charge, and the other one is the LED that they use. Right, so they did a performance analysis between the supercapacitor and the lithium-ion battery. They put together a Pew chart, which is basically the way they've done it is you put your specs that you need the system to comply with in as your baseline, right? They've got various things. And then you take all of your options, and it might only be two, but it could be more than two, and you say whether the this particular option, in this case the supercapacitor, is better or worse or the same as these numbers. And you can see the supercapacitor was good for charge time and service life, but not great for cell voltage, specific energy, and the cost. Right, so not quite sure why they said 0 and gave a plus to lithium-ion. I don't think anybody's was going to pay them to use a lithium-ion battery. But anyway, they decided that the lithium-ion approach was better. And then they had to build a coil, a generator, to tap into the motion. So they investigated the inductance formula, and they decided that they needed to design their copper coil in order to get it. And then this is their block diagram of what's supposed to happen. There's the copper coil piece, there's the rechargeable battery piece, there's a boost or buck converter up to get more usable voltage out of the battery to power the LED. Right, and they did a first run at how that might look in terms of I think this was just in multisim from the looks of things. But multisim or LTSpice or something like that is good. And then they had a reasonably detailed schedule, and my requirement on the schedule is right, apart from things like enjoy summer break, right? My requirement on the schedule is, and you can see they took it to heart, no task longer than a week. Right, so that means you're going to have to come up with a 3.5 month schedule for next semester that is broken down by less than a week. And it's gone again. I wish it would stop doing that. Let's just kill that and start again. Okay, let's have a look at lit. So lit, the idea here was to have a for a store to have a programmable display on the outside, right? And their system overview is basically to looks like that. They wanted to be able to talk to the display using a Bluetooth module, and they came up with some hardware sketches and circuit-ish sketches and use case diagram. And for me, the schedule wasn't as detailed as it needed to be. This was good. And the other thing I'd suggest is when you're updating schedules and budgets, try and put them in exactly the same format and even in the same table sometimes. You don't have to put tables in a document in portrait mode. You can turn this page around and have it in landscape, so you can have a wider one. It's much easier to see differences in schedules when everything's captured in the same format, right? And that's one comment I had about this one, right? Their original proposal was this, but then they did the new budget in a completely different format, right? And that makes it hard to do the comparison. Sure, we can compare the bottom line number, right? 132 versus 114. And then try and use, and they've actually done a reasonable job here, try and use some standard reference formatting, and I suggest you use the IEEE citation style. Right, IEEE citation style. And there's the IEEE one, the Chicago Public Library has it too. Right, so there's the reference guide. But basically it's, where are we? There. It's basically numbers, usually in square brackets, author, title, if it's online, the URL that it's available at, and the time you last accessed it. You should also try and get when it was published. And I have this cute little JavaScript thing that tells me when particular pages were published. For example, this one was published on June 7th, 2020. Right. That only works for static pages, unfortunately. For this one, for example, it's just going to give me the current time, which isn't as useful because a lot of web pages these days are dynamically produced. So, but this particular one is a is just a file. So you can get the date on the file pretty easily. Okay. And let's just do bear aware alarm. Right, so the idea with this one is they wanted to scare bears away. And do it using an ultrasound alarm. So they had quite a bit of background information about bears, and they wanted to do it using, they wanted to be able to go camping and scare bears away. So they wanted to be able to identify the bear using a camera, and then if they identified a bear using the camera to both send an alert via a text message, and also to activate the alarm. So that's their block diagram. It doesn't have to be particularly detailed at this stage, right? At this stage, the block diagram is going to be pretty coarsely granular. It's not going to have detail. Each individual one of these may need more detail, right, in this document, but the overall block diagram should be, there are probably 5, 6, 7 components to it. But the aim is to identify what you have to develop. I personally would prefer using that deployment diagram that I showed you out of Lucid, but provided you can identify both the hardware component and the software components clearly, I really don't care one way or the other, just so long as it does document what you're going to do. And then there's some more detail and the materials, and I've got a schematic, right? So this one's okay. I would prefer to see schematics in something like KiCad, something that's a bit more like a professional package. And again, most of them, KiCad has components for just about everything you can buy, or it's pretty easy to take an existing one. Excuse me. And it's pretty easy to take an existing one and modify it. Okay, and they even had some Python code to send stuff out, right? State diagram, flowchart. This one was okay, but the thing with the problem with this sort of a schedule is I like to see individual names associated with each deliverable or with each task. And if you just have one task per week, then maybe you've got you've only got one of the three of you working each week, and it's probably not right, but that's what that says to me when you have a proposed schedule like that. And then this was okay. They decided that their initial thought of using a thermographic camera was a little out of their price range, so they just went with a smaller Pi camera, and they got okay results. In the end, it came out pretty well. And I didn't like the general references here are good, right? That's okay. I would have liked to have seen the author's name at the beginning, but try not to reference URLs like this. When you go in your browser, right, and you bookmark a page, the name that it bookmarks is what I would call the title of the page, right? So for example, this one, the title of the page is the title of the paper, but it also has Stack Overflow blog -- Stack Overflow blog at the end. That is the full title of the web page. This particular web page has an author, Zara Cooper, right? So make sure you include her name. It has a publication date. Make sure you include the publication date. I'm not saying you need to reference this page. I'm just using this page as an example. Right? Just because you can click on a link doesn't mean that's all you need to reference. The reason is because links change. And if you just give a link and no other supporting information or background information, like the author, like the publication date, then it's going to be hard for somebody to Google that particular piece of information. So if you have the author, if you have the title, I should be able to just take that title. Let's see if I can take that title. Right, I'm going to copy the title. I should be able to take the title and it should turn up in Google as one of the first responses in Google, even if the URL that I got it from has changed. Right? See, that one's dead. It's interesting. That one's not the same thing. That's okay. It's just a short reference to the one we're interested in. Right, so please please don't do this. Even though this is actually just about the particular components that they wanted to buy, it's still better to have more detail about it. Amazon's usually pretty good about including detail in each of its URLs, but still, you're better off having more information about each item. And again, in the case of materials like these, the things that you would use for the author is the company that produces the item. If you know the company that produces the item, then it's probably got a full name for the product. That should be the title of the product. If you're giving a URL to it, you should see if you can figure out when the page was published. Sometimes it's not. So make sure you give the date last accessed like they have down here, right? They've that's an okay way to say when you last accessed the particular page. Okay. Any questions so far? No? Okay. So I don't know what your preferred suite of tools is. These are the things that I believe are available in the SEST desktops in the app server. I think I know LTSpice is. I think KiCad is available. KiCad is available for download, so you can install it. So is LTSpice. There may be a way to get Fusion. Looks like there's a free software version for if you're a student. Same with NX12. You may have your own thoughts on the sort of tool to use for CAD. I know there's at least 2 of the groups are interested in 3D printing. So do you currently have a suggested tool for using for producing CAD for 3D printing? Anybody? No?
Yeah, Yeah, I don't believe so.
Okay. So again, I think they're available. Let's just go to the app server and check. So this is the engineering and science one. Engineering, science and technology one. I think that's the one to use. I could be wrong. I haven't used it for a bit, so I'm pretty sure it's got LTSpice because I think some of my CET497 students are using it. So what have we got? Mastercam, Automation Studio, Cam.io, AutoCAD. Let's see what else we got. There's Autodesk. Let's see what's under Autodesk. Sorry, let me just go back here and say, oops, go back here. So Fusion 360. No Fusion 360. That's interesting. Yeah, so I think NX is the one you want. I believe somewhere. Yeah, so I think that's the one you want from Siemens. It might be a little heavy duty. If you find something else, please let me know. If you don't know, I'd suggest asking people on Broderick's Student Lounge, because I know Chris Farley, former student, and Ryan Neninger, also a former student, know quite a bit about that stuff. And Ryan, I think, gave me a book about NX12, and I'm happy to loan that out if I can remember where it got to. I moved my office over the previous break, so things are still a little bit disorganized. Okay, so and then let's just see if KiCad's there. No KiCad, but again, KiCad's downloadable, so you should be able to get that. Okay, and I've got LTSpice installed down here somewhere. No, not that one, that one. Where's it gone? There it is. Right, so you can use LTSpice. Yeah, where's it gone? So you can't quit, cancel, and quit. Okay. There are lots of people who've spent a lot of time trying to figure out how to do a nice product. Not that what we're going to get out of 498 at the end of next semester is necessarily a product, but it should be close to a good prototype, right? And Peter Marks is one of the people who's thought about this stuff a lot. And the other guy I would recommend reading if you're so inclined is a guy called Steve Eppinger. His co-author Ulrich I've forgotten his co-author's first name. Anyway, they wrote a book, Ulrich and Eppinger, and again, it's tells you a lot about how to design products. But I like Peter Marx's checklist because it has a nice acronym, right? The acronym, if you can read down the capitals here, is appeals dollars, right? And the first piece is availability. How is the product going to be taken to market? Is it available to be downloaded? Do you have to buy something from a big box store? Do you have to have somebody come to your house and install it? Think about those sorts of things, about the availability of your product. Packaging. We can't just sell a raw printed circuit board, right? Maybe we can for some people, but the general public, the packaging has to look nice, it has to fit nicely, it has to work for whatever the thing is that we're trying to sell. So physical form, fit, and appearance. Years ago, did I have it there? There we go. So years ago, I worked on this device, and I don't know, it's a bit hard to see, but this blue thing in the middle is a 3D camera, and it was a wonderful piece of electronics, but the mechanical engineering guys that I talked to, that I worked with, that were designing the mount for it into our this is an XY robot, that's one direction, and then that's the other direction, and they hated this device because this side was all curved, so they couldn't mount it there. This thing that stuck out was all curved, so they couldn't mount it there. And the only place they had for mounting was the flat back, right? The place where it is actually mounted. So the reason the company that sold this camera made it pretty blue and with all the curves is to be able to, sell it. But the people who actually bought it and needed to use it weren't that impressed with that sort of layout. They would have, because we were integrating that device into a larger product, the mechanical engineering people who were designing it for me would have much preferred just a box, right? A rectangular prism rather than this curvy looking thing. So think about that when it comes to the packaging. So we've talked about availability. Performance. Now each of you has different performance metrics, right? There's going to be time metrics, there's going to be power metrics, there's going to be other metrics. So, but mostly around the thing that you're actually trying to do, okay? The principal useful functions. So make sure you figure out what they are and why they're good. A software engineer that I used to work with we were writing mobile apps, and his take was if you're explaining, you're losing, right? The idea being that if you have an app, and that app needs a tutorial associated with it in order for it to explain how to use it, then you're losing. Your app is not designed well from a simplicity or an ergonomics viewpoint, right? Because if the app uses standard idioms for sharing and for cutting and pasting and for all of that sort of stuff, for navigation, then you don't have to tell people how to navigate it. If it uses standard icons for notifications and for friends and for likes and all that sort of stuff, you don't have to tell people what they're about because they just know. So think about ease of use. Probably not as relevant for what we're doing, but certainly reliability is something that you're going to want to be able to make some sort of an assurance about, right? Is the how often will the parking system not detect a car? How often will the fridge project not take a picture when it's supposed to? How often will the security system throw a false alarm, right? They're the sorts of assurances that each project needs to make about how it's going to perform. Life cycle costs, right? There's usually two things to do with costs. One of them is the total first cost of ownership, which is the one down the bottom here, right? How much does it take to get the thing installed? But then the other thing you need to understand is how, as the thing stays there, what does it cost to run the system? And for our three, the main cost, I think, is going to be power, but there may be some pieces, maybe the drone crashes and you need to replace it. What's that look like? Maybe the fridge camera needs to be replaced. What does that look like, right? What are the ongoing costs? And then social acceptance is a biggie, and it's different for each project here, but regulations and codes. I'm pretty sure there are codes around how a fridge is supposed to operate in terms of food safety. Does your project meet those? Find out what they are. I'm pretty sure the FAA has regulations about flying drones. Find out what they are, particularly if the drone is going to be an autonomous drone. There might be some extra regulations that the FAA imposes that you need to meet. It may not be if it's only low flight and all that sort of stuff. It might be okay, but make sure it is okay. And the parking, I'm sure there are regulations about how parking stations are supposed to operate. So find some codes around those. That's probably more likely municipal codes, and they may differ by jurisdiction. They may differ by city or town, but see if you can find out those. And it's gone again. If you don't mind, I just have to quickly do something. I'll be back in about 2 minutes, okay? Sorry. Okay, sorry about that. So where are we? Yeah, so I talked about, anybody got any questions about those things? Again, it's not a complete list, but it does get you thinking about some stuff that sometimes people don't think about. And I mentioned this briefly about in one of the preliminary design reports from last year, right? A Pew chart. And again, the aim is to it's not about automatic decision making. It's about explaining why you've made the decision you've made, right? So in this example, you've got 5 criteria, and the baseline is usually the way I would do it is you would have one option is where you're starting with, that's your thought, your starting position, and then these other options are things that maybe you could do better or could do things better. And if option 1 is better than the baseline, you give it a plus, and if option 1 is worse than the baseline, you give it a minus, and if it's the same as the baseline, you give it a 0. And then you basically just pluses and minus cancel each other out. Zeros don't add anything. So option 2 in this case has got 3 stars, which means like it sounds like it's pretty good. The only thing it's worse than the baseline on is criterion 2, right? So, but at least it might be okay that it's worse there if it's better everywhere else. But again, it's not about, yes, we have to now use option 2. It's about these are the options we considered, and we've decided to go with option 2, and this is why. And this is why criterion 2 doesn't matter as much compared with criteria 4 and 5 maybe. So I was going to give you a bit of a lecture about TPM, that's traditional project management, but I don't know how useful it would be. As you saw in at least one of those previous preliminary design projects, documents, they used Microsoft Project, right? So I think Project is available on the central desktop. Let's just check if I can figure out where it got to. There we go. Yeah, there's Project there. Right, so Microsoft Project lets you put in task name, how long it's going to be, when you want it to start, it'll figure out, if you tell it duration and start, it'll tell you what the finish date is. You can set predecessors based on the ID of the task, right? And you can even assign people to doing each task. And then it'll very easily give you what's called a Gantt chart. over here, which shows you the order that the tasks come in and their durations in a sort of a bar graph, a horizontal bar graph format. Right, I'd suggest at least trying to use it to have a go. Early next semester we might have a chat about how that can be used. However, what I'm going to be doing with in each session next semester is I'm going to be asking you to give me a green light, a yellow light, or a red light status report about each project. And that'll, as it says, green says the don't know why it's so the project is progressing according to plan. Yellow or amber says that the project has a problem, but there's a get well plan in place and the situation will correct. And red means help. Okay, and this is taken from a book I use when I teach software project management called Wysocki, Effective Project Management. Right, so we looked at this earlier. These are the things we need to be sure of before we can proceed to the detailed design, right? Which is the first part of 498. This is the preliminary design review, PDR. I'm not going to talk through this again, but you should have a look through it. And this is the preliminary design document rubric, right? Introduction, system overview, hardware description, software description, schedule, budget, conclusions. Okay, and I haven't put the preliminary design document and assignment or the presentation assignment up in Blackboard yet, but I will over the next week or so. And basically it's going to be a Blackboard implementation of this rubric. And then the presentation is more about the presentation, also about the content, but it's like introducing the team members. And then most of the rest of the left-hand side down to number 11 is about the content, right? But then the right-hand side, speaker is audible, speaker's body language is a bit hard to see in a virtual environment. Speaker demonstrates positive feelings. Speaker demonstrates command of the subject matter. Speaker is poised when questioned. Presentation is well organized. Visual aids are appropriate. All aspects of the visual aids are visible, and grammar and spelling is acceptable. So I think some of you took it a bit too much to heart, but the things that I dislike about presentations are no walls of text, and make sure that diagrams are readable. And with any presentation, practice it before you deliver it. At least once, preferably 2 or 3 times. So that's where we are. I don't have too much more to tell you, if you have access to OneNote, I've put all 6 of the previous year's preliminary design reports here, so you can see what they've done. Be aware, none of these got full marks, so there's some good stuff, right? But they're not perfect. Pay attention to some of the things that I've talked about during today's presentation. Okay, does anybody have any questions? Do I owe anybody anything apart from grades? I need to get my grading done.
No, sir, I don't believe so.
Okay, I apologise. I should try and get a bit more interactive. This was me talking at you a bit too much, but I suppose you were talking at me last week, so it's only fair. So let's just have a look at next week's, what's on the schedule for next week, right? So the aim for next week is that you will have time in class to work on your PDR document, and what I'd suggest is let me get that template together based on the website that I put up, and that way we can all be on the same page as far as what sort of document I'm looking for. And you'll have basically, the nice thing about that template is that it gives you a checklist of stuff that you need to do. Okay, and in a little bit more detail than the rubrics do. Okay. It's finishing a little bit early, but let's leave it there for today. Thank you very much for your attention.
Have a good weekend.
Yep, you too. Have a good weekend, everyone.